let's talk about. So today, I mean, this is big topic, and we are here to share our journey about adopting the OpenTelemetry in our own product, right? We are observability solution, and here we are. So myself, Vashistha, you can call. Don't go with the big name. Actually, you can call me Vash. So I'm actually head of engineering for data ingestion layer for the Broadcom. And Martin, you can, here's Martin.
Yes, I'm Martin, and I'm a software architect working with Vashistha.
All right. So anybody who joined late, we'll be talking about the scaling the modern workloads. Be it like, data coming from mobile devices, data coming from browser to mainframe. So here is our agenda. I'll be talking briefly about our own product suite a little bit, and we'll talk about some of the capability that it has, and we will introduce to the scaling challenges which we got, and how we actually solve that, and give back to the hotel community, and then we'll share about some of the commitments, outcomes. Okay, so this is, again, when you give a work to some of the marketing guys, they come up with like very nice, cool diagrams, sophisticated ones. However, actually, the key message is that our product is like, the mission is that one product, one solution for all of the data from different dimensions. You can see like mobile, browser, synthetics, data coming from mainframe on toward the right side. You can see all the data from the legacy platforms, the kicks regions, and then the cloud and everything. So all of this data, the message is that we connect all of these data together to show the insights. Again, little bit, very sophisticated slide, but the core is that we got the platform. Left-hand side, you can see focus on the data coming from the infrastructure based, like, server, databases, VMs, and so forth. And then the big piece we have actually integrated is all the data hotel signals, right? All the key pillars like the traces, metrics, logs, and events. And also, right, we can actually ingest the data from all the other third-party vendors. Like, you can see like, name it like Datadog, SolarWinds, Dynatrace, and so forth. The key message here is that you can actually get all of these data in the platform, and you can actually do the alarm insight, SLIs, SLOs, name it like anomaly detection, and then the custom dashboarding as well, right? The new addition is that we recently launched the Watchtower platform from Broadcom, right, which is the mainframe side of the telemetry and insights, and we have integrated that as well. So you can see on the bottom, right, the data coming from the Linux, synthetics, RAM, which is called like real user monitoring, and then the distributed tracing as well. So all of these, right, and then actually the right-hand side, you can see that it is integrated well into the other automated systems, the automation, ticketing notification, ServiceNow, and BMCs. So all of this is actually being covered through a single platform. Like a quick sneak peek into some of the pages. A very nice services view where actually you can have a consolidated view of your services health. A quick brief of the trace viewer where actually you can see all of the OpenTelemetry related, or like, be it hotel data, be it data coming from the proprietary agents. All of the things is really visualized through the trace viewer. Some of the GenAI related stuff where actually it takes all of the data together, analyze it, and give you a summary, and give you the the next action steps as well. You can visualize your topology as well. On the topology, you can also do the alerting, based on their health status. Well, why I'm talking all of this, right? This is all the product. The key crux is that when we go inside, I'll hand over to Martin, who will talk about a little bit about where actually we are going to focus when we talk about why we are here today, right, in the hotel community day, is the fact that when we adopted the OpenTelemetry integration, right? There are certain nuances which Martin will discuss about in this diagram. Over to you, Martin.
Okay, thank you, Vashistha. So this is basically now the picture of our attempt to ingest OpenTelemetry data into our TXO2 backend. And so this is on the left, you see basically observed applications, usually custom applications, and they are being producing telemetry using OpenTelemetry SDKs, APIs, or auto-instrumentation agents. And we expect customers to have collect one or more OpenTelemetry collectors and with OpenTelemetry pipeline. And we expect them to have OpenTelemetry exporter that they provision with our API gateway endpoint. And also they need to provision the authentication authorization header with authentication token so that they can get in. On the right, basically is our TXO2 cluster. And the cluster itself contains dozens and dozens of services. We are showing only the new ones that we added to support OpenTelemetry ingestion. The API gateway is the first point of entry for all the signals, OpenTelemetry signals. It does the authentication, as I said. It does the rate limiting, validation, and routing to the back services. So as you see from the gateway, the metric and trace signals take different routes. The trace signals go into the trace ingester. And the trace ingester, basically, we adapted the OpenTelemetry Collector pipeline. What we did is we simply replaced the exporter with our custom TXO2 exporter that does the protocol conversion from Spanly, to our TXO2 trace component protocol format. And luckily, this conversion is relatively painless. We just take strings and put them into different format. And it's stateless, therefore. And it can be deployed with a simple replica set, the trace ingesters, nothing special there. However, on the metric side, you can see that things are much more complicated. And so we're going to go over the reasons why this is there. So first you see that total metrics ingester is a stateful set. And the reason why it needs to be stateful set is the reason how we store our metrics in our TXO2 metric storage. The metric storage, our TXO2 metric storage is divided into two separate databases, essentially. One is for metadata and one is for time series. Initially, a few years back, we had one relational database for all the metadata together, but that did not perform at all. It was basically, once you started getting massive amount of metrics, the database blew up really quickly and it wasn't efficient enough. So we came up with a strategy where we have one metadata database that maps metric names, types, sources, and attributes to a unique identifier. And once you register in a metadata database, get back with a unique identifier, you push time series data to the time series database with just unique identifier and a bunch of numbers. And that can be optimized very well into really optimized storage and optimized throughput for time series data. But the side effect of that is that the metadata registration is relatively expensive, and we can't do that very often. And what happens is that OpenTelemetry ingester needs to register any given metric time series and maintain the unique identifier. And that needs to be saved in a persistent cache, and therefore it has to be stateful set. Now, why do we need a metric load balancer? So we need a load balancer because if any metric can go randomly to any stateful set instance, it will result in cache duplication and still multiple metric registrations. And therefore, we introduced the load balancer, which is essentially a stream OpenTelemetry Collector pipeline with a load balancer exporter. So the load balancer exporter basically does the resource attribute-based routing, making sure that each each metric from each same source goes always to the same stateful set instance. So this architecture worked very well for us initially. We did moderately high load testing and it worked fine. But then we got hit with a new requirements. Basically, it turns out that some of our customers had a humongous deployments of applications. We had up to 4 million data points per second, and they came up with 600 big cardinality explosion, 600 million unique metric series per day. And when we piped that into the, let's go to the next slide. When we went piped that load into our ingester architecture, it pretty much broke down. It ran initially a little while, and then it broke down. And so the reason why it broke down was basically that our ingestion pipeline was synchronous. From the API gateway, request was made to the load balancer, which resulted in a request in a ingester, metric ingester, and all these requests stayed alive while the backend was processed fully. And what happened was that as some event happened in a system where, for example, one stateful set instance was restarted, resulting in unbalancing of the metrics to the other instances, which caused metric registrations flood of metric registrations in a backend, and that caused the metadata database jam, which backed up the ingesters. As the ingester got backed up, it backed up the number of coroutines was exploding, memory usage exploding, and this all propagated backwards into the load balancer and into the API gateway. So we realized we have to change our architecture drastically to make it more robust. And let's go to the next slide. So what we did is we broke down the synchronous pipeline by introducing a Kafka topic between the load balancer and the metric ingester. And so essentially what we did is we replaced the OTLP exporter in a load balancer pipeline with Kafka exporter, and we replaced the OTLP receiver on a metric ingester pipeline with a Kafka receiver. Now the exporter, OpenTelemetry exporter has a feature where you can route partition the data according to resource attributes. So that satisfied our requirement of sending messages from the same source are always sent to the same topic partitions, so they can be handled the same way. But on the metric Kafka receiver side, when initially we start up, receivers instances get all assigned the partitions, but by default, Kafka receiver only supported the range partition assignment, which is default. And when the instance was restarted, it was assigned same instance was assigned different range, and that broke down again our persistent cache and caused cache duplication and extra metric registrations. So what we did is that ended up being our first community contribution. We made a fork of Kafka receiver, added sticky partitioning assignment strategy to it, and yeah, that worked. So if we go to the next slide. So this is what we saw. So there was a lot of celebration in the room, and we finally were able to look at the graph of metric consumption, saying we can maintain 4 million points per second. And I guess, what's our time? Oh, we have time. Okay. So what are the benefits of Kafka ingestion? So first of all, it can handle really high throughput. We can do up to 4 million metrics sets per second, and effortlessly, and 1 million spans through the trace. The other big benefit was that the Kafka topic acts as a buffer then backend starts choking for some reason. So if there's any hiccups in the backend, Kafka topic partitions build up, but ingesters can take the time and if problems get resolved, empty the topic again. Also, then there is a failure to in a database operation in the backend. Kafka provides easy way of resuming from offset and no reason to drop data there. Stable memory use. We have this asynchronous pipeline allowed us to basically keep memory stable across all the path. There is no bloods, no cube loads, and no cheesy storms. And finally, that allowed us to still maintain the stateful metric processing with a sticky rebalance. Okay, so here are basically the Kafka properties for the configuration properties that we came up with. Our max message size ended up being about 6 megabytes. Retention period 3 hours, so we can absorb a large backend disturbances. Max group session time of 2 minutes. Replication factor 2. Consumer sticky partitions, and and it's not mentioned here, we had 5 Kafka brokers in our cluster, though they're not only for our hotel. There's basically Kafka brokers were already there for our product, other reasons in our product. It's just we added it there.
Okay, so I'll take it. Okay. So with all that presentation, right, the key message here is that the specifics was that we were actually in a situation where the requirement of statefulness was there, and the problem which we are trying to address is that when you have a scaling requirement where the stateful set is a requirement, then actually, and if you end up using like similar to Kafka, you can use the sticky partitioning scheme, which we have added. And then this whole of this ingestion is based on the scaling the OTel collector design itself. We have actually forked it and we have started scaling that. So that worked pretty well on the OTel side of the house. Then again, so the adoption rate, as I said, so we have actually adopted, and we have in fact integrated all the, other than the proprietary agents we had, we have integrated all the OTel signals, right, coming from, and also the homegrown mainframe OTel signals as well, we have integrated with. And again, all these 4 pillars, right, metrics, events, logs, and traces, we have got all of them covered. And then the contributions as such, right, as I just mentioned, right, the sticky partitioning, right, rebalancing strategy for the Kafka receiver, that's one. And we have actually recently did the log rotation as well, which is required for our own use. We have actually started very recently on this community. We are very proud to take the advantage of the community and also giving it back, back to the community. So with that, I'll be probably ending up this slide here. Again, we have got our OTel solution, at its enterprise scale. And then for, as I said, for the stateful metrics, having this, scalable design. And the best practices, we just shared. With that, we'll be ending up this session. Thank you very much. And we have 5 minutes for any questions or anything if you guys have. Happy to share. I think this. I think probably they will record, or I don't know. Generally, that's a good idea.
Thank you. So for such a diverse, from mobile to such workloads, what was the biggest challenge across? Is it telemetry across all those workloads from mobile to mainframes you came across, in terms of it was policy, or it was some other stuff which was the biggest challenge from?
Yeah, I think that's a very good question, right? So if you look at the one of the keynote sessions, also we got right the semantic convention on the OpenTel as well. So for all the legacy signals, right, they have their own format. The OTel has got its own format. When it comes to the standardized tools, right, it is important that they come to the one convention, right? And what we have done is that we have started actually getting the OTel data, whatever the semantic convention it is, right? And what is our proprietary one? We actually have the transformation layer, which basically takes and keeps is the OTel data as is, while still maintaining the proprietary data in their own way, because some of the customers are still very much habitual to see like that. So it's kind of, well, still it is a mix of things. However, in terms of our back-end systems, right, it is still taking all of them and trying to unify to give a different view. So of course that is a challenge, but we were able to resolve by taking the OTel data as is, not changing that much, and still mixing this along with our own data. So the context propagation is still very unique, and it is following the standard convention there. So hope that helps. I think.
Thank you. Could you describe a little bit if you had any decisions or sort of how you decided to use the standard OTel collector on your ingestion side versus maybe like handwriting something that accepts the same protocol, or if you compared other solutions?
That I think, sorry, I think that's Martin. You can add me. That's a very good question. I think we joined late in that party, right? Where there was a huge requirement coming up, right, from the vendors, like from our own customers. Instead of in addition to giving the proprietary data, they were also telling this, they have the signals coming from OTel. And for us to give the time and value to the customers, right, what was important for us to do it at a scale, not changing the OTel signals in a way that it just undermines the its own convention. And to do so, right, our own backend systems, when we started bringing it, right, as I think this gentleman asked, right, the mix of data was obviously a problem, right? Then we have its own model and the OTel has its own model. And obviously we were coming from all the way from the legacy regions. So we experimented with, a couple of architecture. We found that this architecture, which is very good architecture, I would say, I really appreciate that architecture which is got. We experimented with that in our labs and we found that it was really very, very well scaling. However, that our own systems were very much stateful, given the other regions. I think we can go in details, right, depending on the time. So this design, when we did in our lab, I think Martin, you can say that how it really folded up.
Most of our legacy services are written in Java, and we considered writing the essentially OpenTelemetry Collector in Java, and we look at this thing and said no. And then once we start looking into the collector architecture and we saw the pipelines and plug and play exporters, processors and receivers, we were like, okay, why? It's all there. We just pick the pieces, we assemble them into our pipeline, and it worked great.
We have one more minute, yeah.
I think you mentioned in the first slide, like the before slide, that you had a database at the metrics section.
Mm-hmm. Yes.
What is that? And what is that? Why did you need it? And like, how did you plug OTel into it?
So our ingestion ends up, what we do is we pipe, we didn't have it enough in slides because we were short on time. We dropped a bunch of slides there. But
I can show a hidden one.
Yeah. So as you can see, basically, this is the database where the UI and the query languages, they go to retrieve the metrics. So these are the core metric database in our backend. And as you can say that basically, we call it our DX02 product, at least internally. So there is a values database and metadata database, and there is this ingester that needs to come. Anybody who inserts data metrics in the database needs to do a registration, gets back an UID, and then inserts time series using the UID, and that's the part that made us stateful.
Did you have to write that custom, or is that something that was
yes,
already
the values database is actually based on RockDB. But it's basically very proprietary implementation that is highly, we spent a lot of time making it very efficient for time series data. So it's basically designed to very efficiently absorb time series data really fast.
So you wrote a custom exporter then?
Yeah, we wrote a custom exporter to that. So our custom exporter and ingester does this registration and insertion values. But it has to maintain persistent cache, and that's why it became stateful. And being stateful is a lot of a headache.
Just to add to that, right, the RocksDB was, again, like the custom adopted RocksDB. So we had some modifications to get it like a scale for the value store. Any other question? I think we are up
I
on
think
time.
we are past time, yeah.
All right. Thank you very much. Have a nice, great day.